All right, in this problem for Module 7, we want to know the molar concentration of an ion in a saturated solution of. Again, this is a KSP problem. I want to know the concentration of one of the species at equilibrium. We did this in Module 4. We were given a K value. We set up an ice table. We found what was there at equilibrium. The only thing new here is the vocabulary. I have a saturated solution. That means I've got an insoluble solid of lead 2 iodide. Nomenclature, again, you got lots of tricks up your sleeve though. So that's the lead plus 2 ion, the iodide ion. The formula of this compound is PbI2. You can Google it. You just have to know enough to know if Google is telling you the right thing. That means my equilibrium reaction that this problem is talking about looks like that. Watch your stoichiometry. And one of the tricks up your sleeve is to actually look at the KSP table, come down to lead, and there is my lead 2 iodide. My KSP is 1.4 times 10 to the minus 8. And let me double check that. 1.4 times 10 to the minus 8 for lead 2 iodide. All right. If I want to know the concentration of the iodide ion at equilibrium, that means I want to know what goes here at equilibrium in my ice table for the iodide ion. Well, how do I do that? I have to set it up in terms of x's. I know I have a certain mass minus x. The left-hand column will always look like this for these insoluble solids. 0 and 0 plus x plus 2x. Watch your stoichiometry. We started working on that back in Module 4. We actually started working on that back in Chem 1. So my equilibrium constant goes for this equation. It's the concentration of lead ion times the concentration of iodide ion squared. Remember, we set these up starting in Module 4. At equilibrium, my lead ion is x, my iodide ion is 2x, and it is squared. And so x times 2x squared is equal to 1.4 times 10 to the minus 8. Watch your math. That means the 2 is also squared, so 4x cubed equals 1.4 times 10 to the minus 8. That's why our algebra skills are necessary. So I'm going to divide both sides by 4. So 1.4 times 10 to the minus 8 divided by 4. And then I'm going to take the cube root. Make sure you can take the cube root on your calculator, or you can plug it into Math Papa if you want to. And I'm getting 1.518 times 10 to the minus 3. If the question asked what is the molar solubility, this would be my answer. This is the molar solubility. The molar solubility is going to be X, but it didn't ask what is the molar solubility. It asked for the molar concentration of iodide ion, which is 2X at equilibrium. So 2X is equal to that iodide ion concentration at equilibrium, and that's 3.036 times 10 to the minus 3. So it looks like 3 times 10 to the minus 3, 3.0 times 10 to the minus 3 molarity is my answer.